All right, so 7.1, simplifying rational expressions. An example of a rational expression. Basically, when you have well, any fraction is considered a rational expression, but the main ones we're talking about are when you have a variable in your denominator. You know, anything that has, like I said, set up as a fraction will be considered your rational expression. Um, so 5 over x plus 7, x plus 3 over x minus 5, x squared plus 3x plus 9 over x squared plus 5x plus 6, and 10 over x. Just regular fractions are also considered rational expressions. But the main ones we're looking at, the new things that we're looking at would be having the variables in our denominator. All right. So the first exercise you'll see in your homework. Okay. All right. So the first one, determine the function values if possible. So we have a rational expression taking that x plus 3 over x minus 5. And if they ask you to find m of 2, all that means that you will plug in 2 where x is. It's 5 on top, 3 on bottom. It should be negative 3, right? All right. So notice it said if possible. If they told you to find f of 5, I said f of 5, m of 5. So you plug in 5, 8 over 0. But cannot have 0 in your denominator. So your answer would be undefined. All right, so whenever you have 0 in your denominator, your answer is undefined. All right, questions on that first one? All right. All right, so this next one, write the domain in set builder notation. The domain will be all of the values that you can use. So you want to evaluate the values that you cannot use. So you ask yourself, what cannot be used for B? In other words, what can I not plug in to this equation? To find that out, you can always set denominator equal to 0 and solve. And this one, it's probably easy to see, but they may come denominators that may be more involved or more complicated. So what you do is set your denominator equal to 0, solve for V. V is equal to -7. And don't forget, that's not a solution. This is the value you cannot use in your equation, because when you plug -7 into your denominator, you get 0. That's what we went and did this for. So this is the value you cannot use. All right, so before we write it in set builder notation, questions on anything that was said so far? One second. Oh, all right. All right, so set builder notation. You started off with your braces, the V, use this long bar, V, all real numbers. I think the way to set it up is so that's how you would do that set builder notation. So you always start off set builder notation with this right here. You have your variable, which is V. That's what we were plugging in for. Have that long bar and then V again. And then you start your description of your, sorry about that, knock my earpiece out. But description of what variables or what values can be plugged in for your variable. So all real numbers except for -7. All right, here, write the domain in interval notation. So here, if you were to look at your number line with -7 involved, you would be coming from -infinity to -7, then -7 to +infinity. So that's the intervals you should set up. -infinity to -7, parentheses for both. That's your union sign. So that represents or, then -7 to +infinity. Questions. All right, so we're gonna do the same directions on this one. All right, so set your denominator equal to 0 to figure out what values that cannot be used, the restrictions. There's another way of looking at this, or maybe they could ask and say, what are the restrictions on A? So that's another way of, phrasing the question. Either way, that's when you would set your denominator equal to 0 and solve. So factors of 9 that will subtract from each other to give us 5 will be 9 and 4. Did I say factors of 9? I mean factors of 36 that will subtract from each other to give us 5. That would be 9 and 34, 9 and 4. The 9 will be positive, the 4 will be negative. Set each piece equal to 0. You have negative 9 here, positive 4 here. So remember, these are not solutions. These are the values that we cannot use. Questions? Any questions? So set builder notation. Oh, we're not done with these. Let's see. All right, forget it. I was looking for something. All right. And then set builder notation. That's set builder notation. But then for our interval notation, we look at our number line, -4 here, -9 here, +4 here. So we have 3 different intervals that we have to give an account for. -infinity to -9, -9 to +4, then 4 to infinity. So you have to write out or give an account for each interval. So you're talking about -infinity to -9, union, -9 to 4, union, then 4 to 9. Oh, I said 9 to infinity. So the parentheses, remember, it says that we get close to 9 and get close to 4. as possible. We just can't use those values. So I can do 4.1, 4.01, 4.000001, but I just cannot use the 4. So that's what using the parentheses and everything and all those intervals say. I can use everything else except for the -9 and the +4. Questions? All right, so when it comes to simplifying rational expressions, directions would just be that, simplify the rational expressions. And what you do is factor the numerator and denominator as much as possible and cancel out what they have in common. So once again, we're leaning on your factoring skills. So make sure they are good going into this chapter. So we have x squared plus 14x plus 45 over x squared plus 2x minus 63. And we want to factor both of them into the binomial factors, 2 sets of parentheses in both cases. So x squared plus 14x plus 45. So our signs are the same. And all we have is x squared. So that's x plus and x plus. Now we need the factors of 45 that will add together to give us 14. And that's 5 times 9. Bottom expression, we have x and x. Back sign is subtraction, so it's going to be plus or minus. And then the factors of 63 that will subtract from each other to give us 2. 7 times 9. And the one that's going to be positive is the 9, the greater, because of that positive 2. All right. So we have x plus 5 times x plus 9 over x plus 9 times x minus 7. Questions before we look to finish off the process? All right, so we're going to cancel out quantities. We have x plus 9 and x plus 9. That's in common with both top and bottom. So on top, we have left x plus 5. On bottom, x minus 7. And that would be your most simplified expression. All right, questions on that last one before we look at the next one? All right, do the same, factor completely the numerator and denominator. Looking at that numerator, we can factor out the GCF of 3. So 3p minus 15 will factor out to give us 3 times the quantity of p minus 5. That next one, we can factor out a 3 as well. So out of that 3p squared minus 75, pull the 3 out, you're left with p squared minus 25. Also, we have a difference of squares. And that p squared minus 25. And that will factor out to give us p plus 5, p minus 5. Now we can cancel out what we have in common. 3's will cancel 4's, and also the p minus 5 will cancel. Don't forget, when everything cancels out, you're left with 1. So that's what we have in the numerator. And that will be 1 over p plus 5. All right, questions. All right, so this one already have your expressions factored, or the n factors. You have p plus 1 times p minus 2 cubed. And then on bottom, you have p plus 1 squared times p minus 2. So you don't want to have to write this out every single time, but just making sure that we get a visual so you know what we're doing when we do a shorthand. So this is what's actually going on. You have 1p plus 1 up top and 3p minus 2s up top. And on bottom, you have 2p plus 1s and 1p minus 2. So you can leave it in factored form moving forward. I was just doing this to make sure we got a visual as to what is canceling out and why. So you would cancel out one of the p plus 1s, and that leaves you with 1 left on bottom. Then you will cancel out one of the p minus 2s, and that will leave you with 2 p minus 2s up top. So that goes back to your exponent rules. You know, if you subtract your exponent rules, subtract your exponents accordingly, then you know, you wouldn't have to write out all of that. So all you had to do was subtract 1 minus 2 for your exponents for p plus 1, then 3 minus 1 for p minus 2, and that would have gave you the proper exponents. All right, questions on that one? All right, let's do one more simplifying, and we'll be good to go. Hold on, this one's like, okay, that's fine. All right, so we have 8y plus 8 up top, 2y squared minus 6y minus 8 on bottom. So up top, we factor out 8, it's y plus 1. Bottom, we can factor out 2, y squared minus 3y minus 4. We can still factor out this trinomial right here. So we're looking at y times y. Back sign subtraction, so that means my signs will be different. And we're looking at the factors of 4 that will multiply, the factors of 4 that will subtract from each other to give us 3, and that's 4 times 1. The 4 should be negative, and the 1 would be positive. All right. Questions on the factorization? All right. 2 divides into 8, leaves us with 4, and y plus 1 will cancel. So up top, we'll have 4, on bottom, y minus 4. And that's where that one will stop. Questions? Any questions?
Professor, I ain't gonna have no questions until I get into the homework.
Well, I'll see you then, sir. So that's it for 7-1. Let's touch on 7-2, and then I'll let you guys go. All right. So 7-2. So we're going to multiply and divide rational expressions. So when it comes to multiplication, don't forget the process. And the process holds true for multiplying rational expressions. If I look at this 9 and 4, and I see terms that can be factored, not factored, but see terms that can cancel out in the top and bottom with anything, I can go ahead and do that before I multiply. So that 9 is 3 times 3, that 4 is 2 times 2. I can cancel out those 2's before I multiply. I can cancel out some 3's before I multiply. And if I do that, the result will be 3 over 2. And so notice I'm emphasizing the process of canceling out before you multiply. So I look at this. So if I have 5r squared s to the fourth over 28r s cubed times 14r squared over 20s squared. So once again, we're looking at this process of canceling before you multiply. 28 is 4 times 7, which would be 2 times 2 times 7. 14 is 2 times 7. 20, 4 times 5, so that'd be 2 times 2 times 5. Questions so far? So even if you don't do the variables yet, because I see we have a lot of variables, maybe you want to bring those together and then reduce, because we can subtract at least the numbers. You want to get those out of the way. So we see that we have a 5 and a 5 that can cancel. We have a 2, another 2. Doesn't matter what 2 you cancel it out with, as long as you only do it once. Then we have a 7 and a 7. See somebody in the chat? All right, I'll give that to you before we leave. All right, so questions about the numbers that I've canceled before I do anything else. So there was a 5 that was in common with the top and bottom, 7 that was in common with the top and bottom, and we only had 1, 2 that was in common with the top and bottom, so we only cancel out one of those 2's. So now with the variables, since we have a lot of them, what I'll do is consolidate my variables and then reduce those at the end. That's simpler than multiplying 5 times 14, 28 times 20, and then reducing that. So we want to get those numbers, those coefficients out of the way. So when we look at top, we have r squared, r squared. So r squared times r squared is r to the fourth. And just s to the fourth. Down bottom, we have 2 times 2 times 2, which is 8. Then we have s cubed and s squared. Couldn't combine that r with anything, but s cubed times s squared would be s to the fifth. So before we reduce these variables, questions on anything I've done. So you most definitely want to make sure you take your time and go through each term separately.
Professor,
Yep,
so we don't go any further, like subtract the R's?
I'm not done.
Oh, okay.
Yeah. I'm not done. I was making sure everybody was with me before I went ahead and did that. But you're absolutely correct. You want to subtract your exponents for each one.
And when they come out negative, what do we do?
Drop it down bottom. So we have this 1/8 that we have, and then r is going to be 4 minus 1 for your exponent. S will be 4 minus 5. So like you said, one of them should be negative. So it's going to be r cubed, and then s to the negative first power. So whatever's positive will go up top, whatever's negative will go down bottom with that 8. So that would be r cubed and then 8s. Yep. Questions before we do another one?
I got a question.
Mm-hmm.
You just can't subtract the exponents when they're in the first form?
You could. I had a lot going on. So I was trying to
Like the 5
compart.
R,
Mm-hmm.
the 5R to the second, S to the fourth, then you got the 28R and S to the third.
Yeah, man. There are multiple ways of doing this. But when you're on the board and I'm trying to teach it, you know what I mean? I'm trying to compartmentalize the
Gotcha.
things that we do to make sure that everybody's clear on what was done and everything like that. Yeah, once you get comfortable with this stuff, there are multiple ways of knocking these things out. Yeah, most definitely.
And the 14 and 20, can we reduce those?
Yep. Could have did that. Yep. Yep.
This is my first time doing this, and I'm looking back over the old stuff,
Mm-hmm.
backtracking in my mind. And I was wondering, could we use the same steps?
Oh yeah. Matter of fact, they are the same steps. It's just the order in which you do it. You know what I mean? I just did it in a different order than what you saw. And really, a lot of times in math, you know, what's easiest is depending upon who's looking at it and what they see at the time.
That's true.
Mm-hmm. So, you know, when you saw this problem, you may have went to say, okay, I'm gonna knock these R's out first. I'm gonna, you know, looking at the first um, expression, you might say, okay, I'm gonna knock these R's out and these S's out first, and
When I,
then
when
say
I
again.
subtract that, when I subtract that R2 from that R, the one goes to the top.
Mm-hmm.
Okay.
Mm-hmm.
I subtract that 4 from that 3, the one goes to the top.
Yep. Yep.
All right. I had nothing in common with the 5 and the 28.
Right.
Then I go to the 14 and 20. I see if I can reduce those fractions.
Mm-hmm.
All right.
Yep. All right, let's do another one. right, so we have 3w plus 21 over 16w to the 6 times 64w to the 6 over 9w plus 63. So once again, it's about factoring completely. And you can factor according to what you see as well. And what I mean by that is I can leave that 16w to the 6 like that, and then break down the 64 as 4 times 16w to the 6. You know, so like I said, once you get comfortable, you know, you don't have to break things all the way down. You just break it down to what you need. And then the next one, factor out factor out 9, and that's what we're looking at. All right. So the w plus 7 will cancel. 16w to the 6, 16w to the 6. Also, we can recognize that in this 9 is 3 times 3. So one of those 3 should cancel for us as well. So what we have left would be 4 up top, and then that 3 down bottom. All right, questions? All right, let's do a few more. Make sure we are good. So we have 7y squared plus 21y plus 14 over 35y plus 35 times y minus 2 over y squared minus 4. So the first one, factor out 7. Y squared plus 3y plus 2. Factor out 35. It's y plus 1. Can't do anything with y minus 2. But y squared minus 4 is the difference of squares. So it's y plus 2, y minus 2. Also, this trinomial can be factored. Might as well write that 35 is 7 times 5. All right, so in that trinomial, y times y give me y squared. And I need those factors of 9. I keep saying 9. Factors of 2 that will add together to give me 3, and that'll be a plus 2 and a plus 1. All right. Questions on factorizations before we cancel? All right. The 7s will cancel with, a 7 and a 7 at 35. Y plus 1 will cancel. Y plus 2 will cancel. And y minus 2 will cancel. So it looks like everything is canceled up top. subtract 1, and then down bottom, have 5 left. All right, questions? All right, so when it comes to division, don't forget the process here. Change division to multiplication, flip the fraction that follows the division sign, and then multiply. So if you can reduce, you go ahead and do so, but if not, multiply across. So all of your multiplication rules hold true once you convert it to multiplication.
It's getting real.
So we have s over s minus 9 divided by s cubed plus 6s squared minus 7s over s squared minus 49. So I always suggest that before you start factoring, that you go ahead and flip the fraction accordingly. Cuts down on confusion. Go ahead and change it to multiplication and deal with it from there. So division changes to multiplication, and that fraction that follows it is flipped. Now, s squared minus 49 is the difference of squares. That's going to be s plus 7, s minus 7. Down bottom, we can factor out s. That's the greatest common factor. And then we can factor out this trinomial. So we have s and s. Then our sign is going to be different because of that back subtraction sign. And we want the factors of 7 that will subtract from each other to give us 6. 1 times 7. So it'd be 7 and -1. That will give us a positive 6. Once you factor completely, you can go ahead and cancel out just like before. Got some s's that will cancel. S minus 7, s plus 7. So 1 is left up top because everything canceled. And then down bottom we have s minus 1. So division is the same as the multiplication. It's just that you have that first step of flipping your fraction that follows the divisional sign. All right. So here we have 6m squared minus 54m divided by m squared minus 9m over m squared minus 10m plus 9. So let's flip that fraction. If you wanted to look at the first one as a fraction, that would just be over 1. And we have m squared minus 10m plus 9 over m squared minus 9m. In the first one, we can factor out 6m. Leaves us with m minus 9. The second one, we have factors of m minus 1 and m minus 9. Down bottom, factor out m, and that's m minus 9. All right. Problems before we cancel. All right. M and M will cancel. M minus 9 will cancel, or I could have canceled out with this one right here. Just remember that you only can cancel it out once. And it looks like that's it, huh? Minus 9, minus 1. Yep. So there's nothing down bottom that's left. So our factorization will be 6 times m minus 1 times m minus 9. All right, questions before we do at least one more. All right, we have 5y minus y squared over y cubed minus 125 divided by y over y squared plus 5y plus 25. So once again, I would suggest that before you factor, you go ahead and flip your fraction. In that first one, we can factor out y as a GCF. So that's y times 5 minus y. Now here, we have a difference of cubes. So let's go down here and do that formula real quick. So difference of cubes, x cubed minus y cubed is equal to x minus y, x squared plus xy plus y squared. All right, so we have y that's being cubed, and then 5 that's being cubed. So it's going to be x, x, y minus 5. So in the formula, y is going to be where x is, 5 is going to be where y is. So it's y squared, y times 5, and then 5 squared. So that factorization will be y minus 5, y squared plus 5y plus 25. right, so make sure you hold on to those formulas from last chapter. So notice I didn't even try to factor out the other trinomial, because if you look at the trinomial we got from the formula, it's the same one as the one that's in our numerator. So now we can cancel out some stuff. So we see that y and y will cancel. Let me go to another color. Y and y will cancel. Here we have y squared plus 5y plus 25. They will cancel. And what we're left with now is 5 minus y over y minus 5. Now be careful, they aren't the same. They can't cancel in the form that they're in. If you were to rearrange your terms and put in y first, that would be negative y plus 5. So they aren't the same. But what we recognize is that both of them have opposite signs. We have negative y and y, positive 5 and negative 5. So if that's the case, if I were to pull a negative out front, now I have the same thing. So y minus 5 will cancel now, and that will leave me with just negative 1. So this type of scenario will always produce a negative 1 when you have opposite signs for each one of your terms. That would give you a negative 1. All right. Any questions? All right. So try the stuff out. See if you get stuck. And if you have any questions, feel free to email me. If not, bring them on next class and we'll knock them out. All right. Any questions or concerns before we close out for the weekend? All right. So you guys have a great weekend. Be safe. And I will see you on Tuesday.
All right, Professor Tucker.